The forest that acts like a continent. Imagine a forest so large it changes the weather, not just locally, globally. A forest so vast it covers 5.5 million square kilometers, bigger than Western Europe, over 20 times the size of the United Kingdom, nearly twice the size of India. This isn't just a jungle. This is the Amazon rainforest. And it doesn't behave like a forest. It behaves like a continent. From space, it looks endless. A dark green ocean stretching across South America. No borders, no clearings, no visible end. But beneath that canopy is something far more powerful than trees. The Amazon generates its own storms. It pumps billions of tons of water into the sky every single day. It absorbs and releases carbon at planetary scale. It controls rainfall patterns thousands of miles away. It contains nearly 10% of all known species on Earth. And yet, most people think they understand it. They call it the planet's lungs. They say it produces 20% of the world's oxygen. They imagine it as peaceful, natural, stable. But the truth is far more extreme. The Amazon is not just life. It is pressure. It is heat. It is energy. It is a living machine that rewrites the atmosphere above it. It hides rivers wider than cities, predators that generate electricity, and regions so dense humans still haven't fully mapped them. This forest doesn't sit quietly on Earth. It shapes it. And if it changes, the planet changes with it. So today we're stepping into a place that is larger than countries, more powerful than weather systems, and more misunderstood than almost any ecosystem on Earth. This is not just a rainforest, this is extreme Earth. Most people imagine the Amazon as a large forest, dense, humid, wild, but still just a forest. That perception collapses the moment you look at the numbers. The Amazon rainforest covers approximately 5.5 million square kilometers. That is not large, that is continental. To understand it properly, you need comparison. The Amazon is over 20 times larger than the United Kingdom, nearly twice the size of India, bigger than Western Europe. If you placed it over the United States, it would stretch from coast to coast. If you placed it over Europe, it would swallow multiple countries at once. This isn't a patch of jungle. It's a system that spans 9 South American nations. Brazil holds the largest share, but the Amazon also extends into Peru, Colombia, Venezuela, Ecuador, Bolivia, Guyana, Suriname, and French Guiana. That's not just territory. That's geopolitical scale. And it's not uniform. Some areas are flooded forests, some are dense canopy, some are dry uplands, some are river systems wider than cities. The Amazon River itself, flowing through this ecosystem, is the largest river on Earth by volume. At points, it stretches over 10 kilometers wide during wet season. And that's just the main channel. There are over 1,100 tributaries feeding into it. The forest wraps around all of it. Imagine trying to walk across something this large. It would take months. Imagine trying to map it. Even with satellites, large areas remain difficult to study due to density and cloud cover. There are still species undiscovered, still regions rarely entered, still communities living with minimal outside contact. That scale changes how you think about it. Because when something is this big, it stops behaving like scenery. It becomes infrastructure. It becomes atmosphere. It becomes influence. Forests this size do not just exist inside the planet. They interact with it. They shape temperature. They shape rainfall. They shape air movement. The Amazon is so large that it affects weather patterns thousands of miles away. And that's where it stops being impressive and starts becoming extreme. Because when a forest is larger than countries, it doesn't just grow, it operates. And once you understand its true size, you begin to understand its true power. You've heard it before. The Amazon produces 20% of the world's oxygen. It's one of the most repeated environmental facts on Earth. It sounds powerful. It sounds urgent. It sounds terrifying. Lose the Amazon, lose the air. But here's the uncomfortable truth. That statement is misleading. The Amazon rainforest absolutely produces enormous amounts of oxygen. Through photosynthesis, its billions of trees absorb carbon dioxide and release oxygen into the atmosphere. On a gross production level, the number is huge. But that's only half the equation, because the Amazon also consumes oxygen. Every tree that photosynthesizes also respires. Every animal that lives there breathes. And most importantly, every fallen leaf, dead branch, and decaying organism is broken down by microbes, and decomposition uses oxygen. In ecosystems as dense and active as the Amazon, the oxygen produced during the day is almost entirely consumed again through respiration and decay. The result? The net oxygen contribution of the Amazon to the global atmosphere is close to zero. It's not supplying 20% of what you breathe. In fact, most of Earth's atmospheric oxygen was produced millions of years ago by ancient marine organisms, and today, a large portion of oxygen production comes from ocean phytoplankton. So if the Amazon isn't the planet's lungs, what is it? The metaphor is wrong, but the importance is not. Because the Amazon doesn't function like lungs, it functions more like a climate regulator. It absorbs massive amounts of carbon dioxide from the atmosphere. Carbon that would otherwise trap heat. Carbon that would intensify warming. Carbon that would alter global weather systems. The Amazon stores billions of tons of carbon in its trees, soil, and vegetation. Think of it as a living vault. But here's where it gets extreme. If that vault weakens, through deforestation, fires, or climate shifts, the system can reverse. Instead of absorbing carbon, it can begin releasing it. A tipping point, where the forest stops stabilizing climate and starts accelerating change. So the 20% oxygen claim may be exaggerated, but the real story is far more serious. The Amazon is not the lungs of the planet. It is one of its stabilizers, a massive carbon regulator, a temperature moderator, a humidity engine. And if something this large shifts behavior, the entire planet feels it, which leads to an even bigger question. If it's not supplying oxygen, what else is it controlling? If the Amazon isn't the planet's lungs, then what is it? It is something far more powerful. The Amazon rainforest is one of the largest carbon regulators on Earth. Every tree in the Amazon is a storage unit. Through photosynthesis, trees absorb carbon dioxide from the atmosphere and store it in their trunks, branches, leaves, and roots. Now multiply that by hundreds of billions of trees. The result is staggering. The Amazon stores an estimated 100 to 120 billion tons of carbon. That is decades worth of global fossil fuel emissions locked inside living biomass. And it doesn't stop there. The soil beneath the forest stores even more. Layer upon layer of decomposed plant matter, organic material built up over thousands of years, all holding carbon, all keeping it out of the atmosphere. This is why the Amazon matters. Not because of oxygen myths, but because of balance. Carbon dioxide traps heat. More carbon in the atmosphere means higher global temperatures. The Amazon acts as a brake, slowing that process, absorbing part of what humanity emits. But here's where it becomes extreme. The system only works if the forest remains intact. When trees are cut down or burned, that stored carbon is released. Back into the air, instantly. What was once locked away becomes fuel for warming. In some regions, scientists have already detected something alarming. Parts of the Amazon are shifting from being a carbon sink to becoming a carbon source. That means instead of absorbing more carbon than they release, they're doing the opposite. And that shift changes everything. Because this forest doesn't just affect South America. It influences the global climate system. The Amazon regulates heat by controlling moisture. Trees pull water from the soil and release it into the atmosphere through transpiration. Billions of trees doing this at once cool the air. The forest acts like a massive evaporative air conditioner. Remove the trees, and temperatures rise, locally and beyond. Higher temperatures dry out the forest. Dry forests burn more easily. Burning releases more carbon. More carbon increases warming. Warming increases drying. This is what scientists call a feedback loop. And once feedback loops begin, they are difficult to stop. This is why the Amazon isn't just large, it's influential. It stabilizes regional climate, it moderates heat extremes, it buffers global carbon levels. If you shrink something this size, you don't just lose trees, you lose a system, a regulating mechanism, a planetary function. And that leads to the next level of its power, because carbon is only part of the story. The Amazon doesn't just manage heat, it moves water through the sky, and what it does with that water affects entire continents. The Amazon makes its own weather. When you look at the Amazon rainforest, you see trees, but what you're really looking at is a weather engine. Because the Amazon doesn't just sit under the atmosphere, it interacts with it on a massive scale. Every single day, billions of trees pull water from the soil, through their roots, up their trunks, into their leaves, and then they release it into the air. This process is called transpiration. One tree releases hundreds of liters of water per day. Now multiply that by hundreds of billions of trees. The numbers become almost impossible to imagine. The Amazon releases an estimated 20 billion tons of water vapor into the atmosphere every single day. That is more water than the Amazon River itself carries to the ocean. Think about that. A forest producing more airborne water than one of the largest rivers on Earth moves across land. This rising moisture forms clouds. Those clouds cool the air. They reflect sunlight. They build into storm systems. Rain falls, and the cycle begins again. But here's where it becomes extreme. Much of the rain that falls in the Amazon doesn't come from the ocean. It comes from the forest itself. The trees recycle water, over and over. Moisture evaporates, condenses, falls as rain, then rises again. It's a closed-loop system, a self-sustaining atmospheric machine. Without the forest, the rain would decline dramatically, because the moisture source would disappear. This is why deforestation affects rainfall patterns. Fewer trees, less transpiration, fewer clouds, less rain, drier forest, and that dryness weakens the system further. But the influence doesn't stop at the forest boundary. The moisture that rises from the Amazon doesn't just fall back down locally, it moves, it travels, carried by atmospheric circulation. It forms what scientists call flying rivers, invisible rivers of water vapor flowing through the sky. These airborne rivers move south and west across South America. They feed rainfall in regions thousands of miles away. Cities, farms, hydroelectric systems. Entire agricultural economies depend on rain that began as moisture released by Amazon trees. So when we say the Amazon makes its own weather, that's not poetic, it's literal. It generates humidity, builds clouds, drives rainfall, and influences wind patterns. Remove enough of it, and regional climate begins to shift. Dry seasons lengthen, temperatures rise, storm behavior changes, because you're not removing scenery, you're removing infrastructure, an atmospheric engine. This is what makes the Amazon extreme Earth. It is not passive, it is active. It shapes heat, it shapes rain, it shapes wind. And when something that large begins to weaken, the weather doesn't just notice, it responds. When scientists talk about the Amazon rainforest, they use a phrase that sounds almost impossible: flying rivers. Not rivers of water flowing on land, but rivers of water moving through the sky. To understand this, picture the Amazon not as trees, but as a giant pump. Every day, billions of trees pull water from deep underground. They release it into the air as vapor. That vapor rises, condenses, forms clouds. But instead of simply raining back down, much of it drifts, carried by powerful atmospheric currents. This airborne moisture forms massive, invisible streams. These flying rivers can stretch thousands of kilometers. They move west, then curve south, crossing countries, crossing borders, feeding rainfall far beyond the Amazon basin, cities in southern Brazil, farmland in Argentina, regions of Bolivia and Paraguay, even parts of the Andes. All receive rain that began inside the rainforest. It is water exported through the sky. Now imagine removing large sections of that forest. Fewer trees mean less moisture rising. Less moisture means weaker flying rivers. Weaker flying rivers mean reduced rainfall in distant regions. This is why deforestation doesn't just affect the Amazon itself. It alters rainfall patterns across South America. Agriculture declines, reservoirs shrink, hydroelectric power drops, droughts intensify. Because the system was interconnected, and once disrupted, it doesn't simply stabilize again. The Amazon's flying rivers are so powerful that they rival traditional river systems in scale. In some estimates, the atmospheric moisture transport from the forest equals or exceeds the flow of major surface rivers. Except you can't see it. You can't photograph it easily. You only notice it when it weakens. This is what makes the Amazon so extreme. It isn't just big on the ground, it's big in the sky. It links land to atmosphere, forest to cloud, tree to storm. The rainforest is not just absorbing sunlight and carbon, it's redistributing water, balancing heat, powering rainfall cycles. And when that balance shifts, the consequences ripple outward, quietly at first, then dramatically. Because flying rivers are not a metaphor, they are infrastructure, invisible highways of moisture holding entire regions together. And if the engine that powers them slows, the droughts that follow won't stay local. They'll travel, just like the water once did. The largest living machine on Earth. When you zoom out far enough, the Amazon rainforest stops looking like an ecosystem. It starts looking like a machine, not built from steel, not powered by electricity, but constructed from roots, rivers, insects, fungi, and sunlight. A biological system operating at planetary scale. Inside the Amazon, there are over 16,000 tree species, hundreds of billions of individual trees, millions of insect species, thousands of birds, mammals, reptiles, and amphibians. Nearly 10% of all known species on Earth live here. That level of biodiversity is not random. It is functional. Each layer of the forest has a role. The canopy captures sunlight. Leaves convert it into energy. Roots pull nutrients from deep soil. Fungi connect trees underground through vast mycelial networks. Predators control prey populations. Insects pollinate plants. Plants feed animals. Animals spread seeds. Everything cycles. Nothing is isolated. It is a closed-loop biological engine. Energy enters through sunlight. It moves through plants, then animals, then decomposers, then back into the soil, and the cycle continues. Every fallen leaf becomes fuel. Every dead branch becomes nutrients. Nothing is wasted. And because the system is so large, it stabilizes itself. If one species declines, others compensate. If one area floods, life adapts. If drought strikes, deep-rooted trees access underground water reserves. The Amazon has evolved resilience over millions of years. But resilience is not immunity. The system depends on balance. Remove too many trees and nutrient cycles weaken. Disrupt rainfall patterns and growth slows. Fragment the forest and biodiversity declines. When enough pieces are removed, the machine struggles. The Amazon works because of density, because of scale, because of interconnection. Every hectare influences the next. Every river connects to another. Every species contributes to the system. It is not a collection of trees. It is infrastructure. Biological infrastructure that regulates temperature, moves water, stores carbon, recycles nutrients, generates oxygen, controls rainfall, supports life. And it does all of this without human management, without maintenance crews, without central control. It is self-organizing, self-repairing, self-sustaining. That's what makes it extreme. This isn't the largest forest in the world by accident. It is the largest living machine on Earth. And machines at this scale do not fail quietly. If they slow down, if they destabilize, the effects don't stay inside the forest. They ripple outward, into climate systems, into agriculture, into global weather patterns. The Amazon doesn't just exist within Earth's system. It is part of the system, an engine running continuously beneath the canopy. And the question is no longer whether it is powerful. The question is how much strain it can absorb before that machine begins to malfunction. If the Amazon rainforest were just large, it would be impressive. But what makes it extraordinary is density. Because this forest doesn't just cover millions of square kilometers, it contains an explosion of life. Scientists estimate that nearly 10% of all known species on Earth live inside the Amazon basin. That means 1 out of every 10 documented species, from insects to birds to mammals, exists here. And that number might be an underestimate, because new species are still being discovered every single year. Over 16,000 tree species grow in the Amazon. To put that in perspective, the entire United Kingdom has fewer than 100 native tree species. In 1 hectare of Amazon rainforest, roughly the size of 2 football pitches, you can find more tree species than exist in some entire countries. Now add the animals. Over 2,300 bird species, hundreds of mammal species, thousands of fish species in the Amazon River and its tributaries. Over 400 species of amphibians, more than 370 types of reptiles, and then there are the insects, millions of them. Some scientists estimate that the Amazon may contain 2.5 million insect species, many undocumented, many unseen, each playing a role in pollination, decomposition, predation, or seed dispersal. This density creates something rare, layered ecosystems. The Amazon is vertically structured. The forest floor is dark and humid. The understory is dense and shadowed. The canopy forms a continuous green ceiling. Above that, emergent trees rise like towers. Each layer supports different species, different interactions, different survival strategies. Some animals never touch the ground. Some never see sunlight. Some exist only in flooded forests, some only in dry uplands. This complexity makes the Amazon extraordinarily resilient, but it also makes it fragile, because biodiversity depends on connection. Predators control prey populations. Prey feed larger species. Plants rely on specific pollinators. Seeds depend on specific animals for dispersal. Remove one species, and others feel the impact. The more complex the system, the more interconnected it becomes. And the Amazon is one of the most interconnected biological systems on Earth. It has evolved over tens of millions of years, through ice ages, through climate shifts, through continental movement. Life adapted, diversified, specialized, until the forest became what it is today, a biological superstructure. No human-designed system matches this scale of interdependence. No artificial network approaches this density of life. And yet, much of it remains undocumented. Entire regions are still poorly studied. Species exist that science hasn't named. Compounds in plants that medicine hasn't discovered. Interactions we don't fully understand. The Amazon is not just biodiversity, it is biological potential, a living archive of evolutionary innovation. And when a forest contains 1/10 of Earth's species, you're not just looking at trees, you're looking at one of the planet's greatest concentrations of life. which raises an uncomfortable question. What happens if a system this dense, this complex, this powerful begins to unravel? For all our satellites, drones, and mapping technology, large parts of the Amazon rainforest remain difficult to access. From above, it looks uniform, an endless green canopy. But beneath that surface is a world that still resists full human control. Some regions are so dense that sunlight barely reaches the ground. Some river systems twist through terrain that floods for months at a time. During wet season, entire forests transform into water worlds. Trees stand submerged. Fish swim between trunks. Land disappears. Then, months later, it reemerges. This constant transformation makes exploration slow and unpredictable. There are areas of the Amazon where roads do not exist, where access requires days of travel by boat, where weather can isolate communities instantly. And in some regions, there are still uncontacted indigenous groups living with minimal or no interaction with the outside world. The Amazon is not just biologically vast, it is culturally layered. Human presence exists here, but it does not dominate everywhere. Even today, new archaeological discoveries reveal that ancient civilizations once lived deep within the forest. Massive earthworks, hidden settlements, geoglyphs only visible from the air. Evidence that parts of the Amazon were shaped by humans thousands of years ago, but then reclaimed by nature. The forest grew back, covered structures, erased visibility, reabsorbed history. That is part of its power. It hides things. The Amazon River itself adds another layer of unpredictability. The river system stretches over 6,400 kilometers. At full flood, it can be wider than many seas. Its currents shift constantly. Channels move. Sandbanks appear and disappear. Navigation is never static. And within those waters live creatures adapted to extreme conditions. Electric fish capable of generating powerful shocks. Predators that rely on murky visibility. Species evolved for flooded forests and oxygen-poor environments. It is an ecosystem that demands adaptation, not control. Even modern science struggles here. Weather systems shift rapidly. Canopy cover blocks satellite clarity. Soil conditions vary dramatically within short distances. The Amazon resists simplification. It resists prediction. And in that resistance lies its extremity. Because most environments humans inhabit are stabilized, engineered, mapped, regulated. The Amazon is not. It is dynamic, shifting, layered, and often indifferent to human presence. Which is why it remains one of the last places on Earth where nature still operates on its own terms. But even systems this vast have limits, and when pressure builds long enough, even the most resilient machine can approach a breaking point. The collapse question. What happens if the system breaks? For millions of years, the Amazon rainforest has operated like a stabilizing force, absorbing carbon, recycling water, generating rainfall, supporting one of the densest concentrations of life on Earth. But every system has thresholds, and scientists are now asking a difficult question. What happens if the Amazon reaches its tipping point? A tipping point is not total destruction, it is a shift, a moment when gradual pressure causes a system to change state. In the Amazon's case, that shift could mean parts of the rainforest transforming into dry savannah, not because all trees disappear overnight, but because the climate balance changes. If deforestation reduces tree cover beyond a critical level, the flying rivers weaken. Less moisture rises, rainfall declines. Longer dry seasons stress trees. Stressed trees die more easily. Dead trees release stored carbon. Released carbon increases global warming. Warming intensifies drought. Drought increases fire. Fire removes more forest. The feedback loop accelerates. This isn't theory. Parts of the Amazon are already experiencing longer dry seasons and more frequent fires. In some regions, carbon absorption has slowed. In others, measurements suggest carbon emissions are increasing. That is what makes this extreme. The Amazon has been one of Earth's stabilizers. If it shifts from stabilizing to amplifying warming, the consequences won't stay inside South America. Rainfall patterns could weaken across agricultural regions. Hydroelectric capacity could decline. Global carbon levels could rise faster. Temperature extremes could intensify, and biodiversity losses would cascade. Because when 10% of known species depend on one system, collapse doesn't mean inconvenience. It means extinction. But here's the complexity. The Amazon is not a single uniform block. Some areas remain relatively intact. Some show resilience. Some are recovering where deforestation has slowed. The tipping point is not guaranteed. It is a risk, a threshold we may or may not cross, which makes this moment critical. Because the Amazon is not just scenery, it is infrastructure, climate infrastructure, biological infrastructure, hydrological infrastructure. And infrastructure can degrade quietly, at first, until suddenly it doesn't. The collapse question is not about alarm, it is about scale. When something 5.5 million square kilometers wide begins to weaken, the effects scale with it. And that's what makes the Amazon one of the most extreme systems on Earth. Not just because it is vast, not just because it is alive, but because its stability matters far beyond its borders. And if it shifts, the planet shifts with it. The Amazon isn't just a forest. When you zoom out far enough, the Amazon rainforest stops looking like trees. It starts looking like infrastructure. 5.5 million square kilometers of living systems, over 20 times the size of the United Kingdom, nearly twice the size of India, bigger than Western Europe, not just large, continental. But its true power isn't just size, it's function. The Amazon absorbs carbon at planetary scale. It releases billions of tons of water into the sky. It creates flying rivers that feed rainfall across an entire continent. It houses nearly 10% of known species. It regulates heat, moves moisture, recycles nutrients, stabilizes climate, and it does all of this quietly, without borders, without governments, without human permission. For years, we called it the planet's lungs. That wasn't entirely accurate. But the deeper truth is even more extreme. The Amazon is not a lung. It's an engine, a climate engine, a biodiversity engine, a hydrological engine. And engines this large don't fail in isolation. If it weakens, rainfall patterns shift. If rainfall shifts, agriculture changes. If agriculture changes, economies change. If carbon balance shifts, global temperatures shift. This is not just about trees, it's about systems. The Amazon behaves less like a forest and more like a living continent. One that influences weather thousands of miles away. One that shapes atmospheric chemistry. One that still contains regions humans barely understand. It is one of the last places on Earth where nature still operates at full scale. Unfiltered, unengineered, extreme. And that's what makes it belong here, on extreme Earth. Because the most powerful forces on this planet aren't always storms or earthquakes. Sometimes, they're green. If you had to choose one system that quietly holds the planet together, would you choose the ocean, the atmosphere, or this forest? Let me know in the comments. And if you want to see what kind of predator evolves inside a system this intense, click the next video on The Fish That Can Stop Your Heart, Electric Eels Explained. Because in extreme Earth, the environment shapes the power, and the power shapes everything.